Hi, in this video, we're talking about the derivation of the equations of motion. By now we know we have about 3 different equations we use to solve for motion, especially when we have constant acceleration. The first being v is equal to u plus at. The second, v squared is equal to u squared plus 2a delta x, and finally delta x is equal to ut plus half at squared. But how do we arrive at these equations? That's what we're going to be finding out. So starting with the first, v is equal to u plus at. How do we get this? So first of all, we'll make an assumption that our acceleration is constant. So once acceleration is constant, it means our instantaneous acceleration and average acceleration must be equal. If that is true, I can simply say A must be equal to AAV. So A, remember, average acceleration, we say it is the change in velocity over change in time, or just time, since the reference point for time is always equal to 0. So if we are to expound this, we have A will be equal to delta V, simply as saying final velocity Vf minus initial velocity Vi all over t. And then if I were to cross multiply, this should be over 1. We have At is equal to V final minus V initial. Alright, making V final the subject formula, we have V final is equal to, so we take minus V1 to the other side, would have V initial plus AT. So then we're going to say V final should be equal to V, and then V initial should be equal to U. And finally, we've arrived at our first equation of motion, which is V is equal to U plus AT. Now moving on to the second one, how do we derive the second one? Of course, we're still going to be assuming constant acceleration. So if we're assuming constant acceleration, and then we're given two velocity vectors in such a way that we have v1 and then we have v final. If we are to find the average of these velocities, we can just add them and then divide it by 2. Now, we're only entitled to do this because acceleration is constant. If acceleration is not constant, we can't get average velocity this way. So we're going to be getting average velocity by using our formula v average must be equal to delta x all over t, that is displacement over time. Now, of course, we said since we're dealing with constant acceleration, we can also add the velocities together and divide by the total number of velocities that we have. Remember, this is average, so we're always concerned with 2 points. So this also will be equal to v average. Now, I can say v average equal to v1 plus vf all over 2, and v average also equal to delta x over t. So I can equate these two equations together, and then I would have delta x over t must be equal to v initial plus v final all over 2. Now, from the first equation, remember we said v final is equal to v initial plus 80. So anywhere I see v final, I want to interchange it or make or substitute its value into this particular equation. So delta x over t will be equal to v1 plus v1 plus at. So everything here over 2. So I can add these two v1s together. Then I have delta x over t equal to 2v1 plus at all over 2. And the next thing to do is to try to separate my quantities. Trying to separate my quantities. Let's just clear this place. And this also. So separating my quantities, I have delta x over t must be equal to 2v1 over 2 plus at over 2. So here 2 can cancel out 2, so I'm only left with v1 here. Then I want to multiply both sides of this equation by t. So that means t dot delta x over t must be equal to v1 dot t plus at over 2 dot t. And finally, t here cancel out this t, so I'm left with delta x be equal to v1t here, okay, plus t times t, that's t squared, and then I can bring out my 1 over 2 forward, so 1 over 2 a t squared. So you can say we derive a second equation of motion. Remember, v1 means our initial velocity, which is the same thing as u in your textbooks, and then t means time, a is our constant acceleration. All right, before rounding up this video, so let's see how we can derive the third equation of motion. Okay. So for the third equation of motion, what we simply want to do is to square our first equation. So we want to square our first equation. By doing that, we have v squared is equal to u squared plus a squared and then t squared. Now we're going to be applying our formulas on how to expound brackets that are squared. What do I mean? So simply, this will be v squared. And since I have everything in this right hand side all squared, I can just write the single part of it and then square the whole brackets like this. And then this will be v squared is equal to u plus at and also u plus at. Okay, so here we have u squared plus uat plus again uat, then finally plus a squared t squared. Okay, so now I want to group these things together. So what do I do? Again, I can roll a line like this. Then we have v squared is equal to u squared now plus 2at plus a squared t squared. Okay, so now I want to factorize. Sorry, there's a u here. I made a mistake. Okay, so 2uat plus a squared and t squared. So I want to factorize these two expressions and see what I can denote from that. Doing that, so I can say what is common to this side here. Okay, so let's bring out what's it called? Let me bring out a. So a is common, 2 is also common, so I can say 2a, bringing out here I'm left with ut plus, because this guy doesn't have 2, so of course I'm still left with at here, 80 squared. Then I have to divide by 2, because once I expound this bracket, I must get back to where I'm coming from. So you can see that this expression here, ut plus at squared, is the same thing as our delta x. So I can now see finally v squared is equal to u squared plus 2a delta x. So this is how we derive our equations of motion. We assume that acceleration is constant. And if acceleration is constant, we can get these equations. All right, bye-bye.